Hello dear students, welcome to Pen and Paper Chemistry on YouTube.
We are continuing with our topic of electrolysis. We have already dealt with the quantitative aspect of it, where we did the Faraday's laws of electrolysis. These have already been covered in separate videos on request of a subscriber. We are now continuing with the qualitative aspect. That means when you electrolyze different solutions, what are the products obtained at each of the electrodes. So let us first start with the very basic thing and let us discuss as to how we determine whether a substance will be an electrolyte or not. Now here I would like to commend one of the students who's been very diligent and answered this question in part 1 very promptly. Very impressed with your sincerity. I will not take name here. It's not good. So let's discuss first as to how we determine whether a particular substance is an electrolyte or not. So what we have over here is we've taken the electrolyte. Now in this case we are taking pure distilled water, right? We connect the electrodes. Practically speaking, we actually deal with platinum electrodes. But if you carry out this experiment on a small scale, you can also start with carbon electrodes. Connect them to a battery, the key, and you can either connect a galvanometer or you can connect a small bulb over here, right? Connect the key, switch it on. That means now it is a closed circuit. If the bulb begins to glow, yes, this will be an electrolyte. But in this case, we notice that because we are using pure distilled water, the bulb does not glow, indicating that pure distilled water is a non-electrolyte, right? So what do we do in order to make it an electrolyte? You know very well that if your hands are wet and you touch an electrical point, we'll get a shock, right? That means water there is conducting electricity. So what causes the water to become a conductor? Yes, if you notice we've put pure over here. Let's make it impure. So how do we make it impure? We can add any substance which will help it to ionize. So it can be a salt like sodium chloride. It can be an acid like hydrochloric acid or sulfuric acid. It can also be an alkali like sodium hydroxide, potassium hydroxide. Any of these substances will help to convert water, which is otherwise a covalent compound, into an ionic compound. And that also is possible because water has a polar covalent nature. So with the result, a small trigger to it. So let's suppose the sodium ions are here. So any small trigger is able to bring about ionization of water as H positive and OH negative, right? So we no longer have pure distilled water. We will have just water over here, and we can use the term, if we are using an acid, we can say that we are using acidulated water, or if we are using sodium chloride, we can say dilute salt solution, right? So in this case, we've got acidulated water. As soon as you add a few drops of the acid to it, you will find that the bulb begins to glow, right? That means pure water is a non-conductor, or sorry, a non-electrolyte to be specific, whereas acidulated water is an electrolyte. What else will you observe? You will observe that there are two gases being evolved over here. Hydrogen and oxygen are evolved at the electrodes. How do I know that they are hydrogen and oxygen? We collect the gases in separate test tubes and conduct the test for hydrogen and oxygen. Now, question. What is the test for hydrogen and oxygen? Please give me the test for hydrogen gas and oxygen gas. Okay. Next, let us now explain the observation. That means, why are these gases being released? On the passage of electric current, water ionizes to give you hydrogen and hydroxyl ions, right? Acidulated, the acid that we are considering over here is H2SO4. H2SO4 ionizes to give you hydrogen ion, just break it down, and sulfate ion. Now, for those who are new to the topic, new to ionization, please understand this plus sign corresponds to the valency that is there. So hydrogen has a valency of 1 and it is behaving as an electropositive ion, so H positive and OH negative. If you are not sure about the symbols and the valencies, there again is a separate video alone on symbols and valencies, the very foundation of chemistry. So please don't skip that at all. Hydrogen, 2H positive and sulfate ions, right? 2 comes from the subscript over here because there are 2 atoms of hydrogen involved in the formation of sulfuric acid. Cut ion. I remember it as ion with a cut, right? So here the ion with a cut are hydrogen ions. Cut ion goes towards cathode. It's not cut ion, I'm pronouncing it like that so that it's easier to recall. It's actually cation. Cation goes towards the cathode. Anion goes towards the anode in electrolysis. At the cathode, what will happen? Now H positive, it's restless, it's short of electrons, it wants to stabilize. You cannot remain restless for a long time. So at the cathode, what happens is H positive. Now which is our electrode cathode over here? The one which is connected to the negative terminal of the battery. Negative terminal means something which is supplying electrons. Now the question arises, why this switch over? In electrochemical cell it was different, in electrolysis it's different. Now understand over here, cathode again is our electrode at which reduction is going to take place. That means there will be gain of electrons at the cathode. Anode on the other hand is the electrode at which oxidation will take place. Again I come back to the simple mnemonics, that is lone. Left hand side oxidation, anode. Oxidation always takes place at anode. Because here the electrons are being supplied at the, at the anode. Whereas electrons are being consumed at the cathode. That is why the switch over. Now coming back to cathode, H positive will gain 1 electron, change to H. Hydrogen, simple atom. Can it exist independently? No, it is not an inert gas. It needs a companion. It goes and finds another companion, another ion which may have got discharged and converted itself to hydrogen atom. The 2 hydrogen atoms now combine to give you hydrogen gas, right? Now at the anode, there is hydroxyl ion, there is sulfate ion. 2 powerful entities. What do? Hydroxyl says, oh, I have negative charge, I want to do away with it and stabilize. Sulfate says, oh, I have 2 negative charge, I am more loaded than you are, I want to offload and stabilize. There's a tussle going on between the two of them. Who wins over here? Yes, it is the hydroxyl which wins. How do we decide? How do we know which ion is the winner in this war of discharging? Yes, we have something what we call as the activity series of ions, or it is also based on the electrode potential or the discharge potential of these ions. I am going to give you a series for the anions which will help you to decipher as to which ion gets discharged first. Do you notice something? Oh, I've written a sentence. Oh, I brought color, not safe for activity. Why have I written this in electrolysis? I am going to derive the activity series of the anions, of the important anions, not all of them, of the anions which are relevant to our study at present and which will cover most of the electrolysis reactions that you will be doing. O, OH negative, I negative, that is iodide, brought, Br negative, color, Cl negative, not, NO3 negative, that's the nitrate ion, safe, SO4 2 negative, sulfate ion, for F negative, activity, right? So what happens here is this is at the top. This gets the first priority whenever discharge has to happen, right? And then the activity decreases. What do we mean by decreases? Means as you go down, the ions will have more tendency to stay as such rather than get discharged, right? This is what we mean by the activity series. In most of the books, you will find the series listed in the opposite order. You'll find fluoride, sulfate, nitrate, chloride, bromide, iodide and hydroxyl. But you have to remember that it is the direction of the series that will make a difference. If you are writing it as F, SO4 2 negative, NO3 negative, now this is the stability order, right? But what I am listing it as is the discharge order, right? So if you want to write starting with hydroxyl, you can also list it as this. It will still mean the same, but the direction of the inequality sign changes. So here I am showing fluoride is greater or stronger in stability compared to sulfate, which is greater than nitrate and so on. Or I can show the other way round. The first thing for you to do is to memorize this activity series of anions. Please understand the question or what is asked of you before listing. If you are asked what will be the discharge potential or what will be the priority order for the discharge of the anions, then your series will be hydroxyl greater than iodide, greater than bromide, chloride, then nitrate, sulfate and fluoride. If on the other hand you are asked about the stability, then fluoride greater than sulfate, greater than nitrate, chloride, bromide, iodide and hydroxyl. So hydroxyl comes in the end. So you have to understand the meaning of the question. Just don't go blindly memorizing, because this will also help you to understand and relate to the texts in different books that you may come across. You'll say, oh, in one book this is the order, in the other book this is the order. See what they are listing it as. I am mentioning both because I want you to relate to the topic and not just blind memorization. Okay? So when we come to the anode, hydroxyl and sulfate, while they are having a war, the series, this is the rule that they have to follow, and hydroxyl gets the priority to get discharged. Discharge means it is loaded with electrons, it loses the electron to form OH. Now it can't stay like that, there's nothing like OH which is stable. So OH atoms, they come together and they form water and oxygen, and I have balanced this equation in order to equalize the number of atoms on both sides. Now let us see hydrogen and oxygen. We want to know how much of hydrogen and how much of oxygen will be formed in this process. Let's see. Now let us see how we balance and add the two equations and we get the final equation as well. So starting with the cathode, we need two hydrogen atoms to form hydrogen gas. So what do? We multiply this equation by 2. Add the two equations, the two hydrogen atoms will get cancelled. Here they are being, this is the product, here these are the reactants. So I have the final equation on the cathode as 2H positive plus 2 electrons gives us H2. Similar operation is done at the anode. What is there? We need 4OH. So 4OH means I will multiply this whole equation by 4. You can either write it like this or you can also show it as this. Both are equally correct. 4OH being generated, 4OH being used up, they get nullified, right? So we are left with 4OH negative gives us 2H2O plus oxygen plus 4 electrons. Always remember, the number of electrons being generated should be equal to the number of electrons being used up, whether it is electrolysis or electrochemical cell. We started with water, ionization of water, right? So H2O ionizes to give you H positive and OH negative. We have got 3 equations now, 1, 2 and 3. First is the initial, then the cathode and the anode. Now we need to equalize. 4 electrons, 2 electrons. What do? Yes, I multiplied this equation also by 2. When we multiply this equation by 2, the number of electrons gets nullified. 2 times 2 is 4 hydrogen ions, whereas only 1 hydrogen ion is being generated by 1 water molecule. I need 4 for the reaction at the cathode. So what do? I multiply this equation also by 4. Anything else missing? 4 hydroxyl, 4 hydroxyl, right? Now let us add it up. Let us see. 2 times 2 is 4 hydrogen being used up and 4 hydrogen being generated. Finish. 4 hydroxyl being used up, 4 hydroxyl being generated. Done with. 4 water being used up, 2 water being obtained back. So we are left with only 2 water on the reactant side. How many hydrogen are we getting? 2 hydrogen. How many oxygen are we getting? 1 oxygen. Right? So 2 moles of hydrogen and 1 mole of oxygen is what we are getting over here. 2 moles of hydrogen and 1 mole of oxygen. Now if you remember Gay-Lussac's law, so 2 moles here would be 2 volumes or 2 liters or 2 milliliters or 2 cc, and 1 cc, 1 liter, 1 mm, whichever unit you choose to express it in, but they should be same. Basically saying that the ratio of hydrogen to oxygen is 2:1 by volume. Please understand this term, by volume. Why am I stressing on this? Because if you express this 2 moles as weights, 1 mole of hydrogen, let me put its atomic weight, that's 2 into 1, right? So that's 2 grams. 2 moles of hydrogen would be 4 grams. This is based on their, yes, the atomic weights. What about oxygen? It's only 1 mole. 1 atom of oxygen is 16. So 2 atoms of oxygen is 32 grams, right? So what is the ratio by weight? 4:32, right? Let me make space and write it with a bit more clarity so that you are able to understand and remember, because this is a very, very important point. So if we are saying by weight, it's 4 grams of hydrogen to 32 grams of oxygen, right? Hydrogen 4, oxygen 32. So what is the ratio by weight? 1:8 by mass or by weight. And this is also which leads us to the formula of water as H2O. Please understand again, the ratio of hydrogen to oxygen obtained by volume is 2:1. Whereas the ratio of hydrogen to oxygen obtained by weight is 1:8. Oh yes, I like the smile, because many a times in multiple choice questions, you'll answer 2:1, but the correct answer is 1:8. Oh, I learned it as 2:1. Why should it be 1:8? Very, very careful. That's why I'm stressing on this topic. This is a very easy topic, but where do the students get caught is in these small nitty-gritties, right? Do stay tuned, because next is part 3, where I'll be taking up electrolysis of what? Copper sulfate solution or some other aqueous solution. And let's see what happens, and we shall continue with part 3 and maybe part 4 as well. See you later. Happy studying.